Good evening, everyone. We will just wait for a few minutes so that everyone else joins. So let's just start. Uh, Hello, myself Anjali Ramashankar Prasad. I am a PMRF scholar at IIT ISM Dhanbad. So from today we are going to start with the course discussion sessions of Essentials of Topology taught by Professor S.P. Tiwari sir. So before starting, let's go back to some of the basic terms that you may have been through last videos of the course. You might have seen week one lectures. So just going through the basic concepts. So you might be knowing about the metric spaces. What is it? So if let X be a non-empty set, if we have a non-empty set X and a function X comma D that is operating from X cross X to R, it is said to be metric or distance function on X if it satisfies the below conditions. Okay, so first one is non-negativity, then comes our second condition, that is d of x comma y is equals to 0 if and only if x is equals to y for all x comma y belongs to x. Similarly, third one is symmetric property, that is d of x comma y is equals to d of y comma x. And fourth one is triangular inequality. So if all these four properties are satisfied, then we can say the given metric space X, the given non-empty set X with respect to metric D, it forms a metric space X comma D. Okay, so for being a metric space, it needs to satisfy all these four properties. Fine. So basically, you have to satisfy non-negativity for all x comma y belongs to x, and then d of x comma y is equals to 0 if and only if x is equals to y for all x comma y belongs to x. And then third one is d of x comma y is equals to d of y comma x, that is our symmetric property. And the fourth one is triangular inequality, that is d of x comma z less than equals to d of xy plus d of y comma z. That is for all x comma y comma z belongs to our non-empty set X. So if all these four properties are satisfied, then a metric D over X is said to be a metric space X comma D. Fine, I hope you don't have any doubt in this. I hope everyone is clear with the definition of metric spaces. Now let's move to the term topological spaces. So here, if we have a non-empty set X and a class tau of subsets of X as a topology and X. So before going forward, can anyone explain what is class? So this topological space, any non-empty set X can be said a topological space with respect to a class tau of subsets of X if it follows all these three axioms. Okay. So first one is that X and empty set should belong to tau, and then the union of any member of sets in tau should belongs to tau, and the intersection of any two sets in tau should also belongs to tau. Okay, so if all these three properties are satisfied by any tau, so it is called as topological space. Okay, so the members of tau are then called tau open sets, or simply we can say it as open sets, and the X, that is our non-empty set, together with tau, it forms a pair X comma tau, that is called as a topological space. Fine. So I hope it's clear to everyone what is topological spaces. So basically you need X, non-empty set X, tau, and if satisfies all these three properties, then X comma tau will be called as topological space. I hope it is clear to everyone. Is there any doubt? So if there is no doubt, so we will move to question number one, our first question of the doubt session. So if you have given f function from R to R, R2 to R, be given by f of x comma y is equals to y, then f inverse of minus 4 comma 4, this closed interval, actually it should be, there's a correction, it is a function f inverse of minus 4 comma 4, this interval, this is equal to, you have to find whether it is A, that is a set consisting of minus 4 comma 4, or B, that is set of real numbers, or C, the vertical strip between the lines y equals minus 4 and y equals 4, or it's D, the horizontal strip between the lines y equals minus 4 and y equals 4. So all of you please try it and see what is the answer, correct option, and let me know the answer. If you have any doubt, you can ask. All of you please solve it. Is there any doubt? You can ask, you can unmute yourself and you can ask your doubts. So the correct answer is D. That is the horizontal strip between the lines y equals minus 4 and y equals 4. Since f inverse of interval minus 4 comma 4 will be what? It will be this set xy belongs to R2 such that y will lie in between minus 4 and 4 and x belongs to R. Okay, so it represents a horizontal strip between the lines y equals minus 4 and y equals 4. You can see visualize it. So what will be according to our function? Its inverse, the inverse of this closed interval will represent this horizontal strip. Fine. Between minus 4 and 4. Now let's move to the next question. That is, in a discrete metric space R, what will be B of 0 comma 10? Okay, so you have to find what is this set represents. So what is B of 0 comma 10? It is a open ball centered at 0 and radius 10. So is it A, B, C or D? Find out which is the correct option. It is empty set or real number set or set minus 10 comma 10 or singleton set 10. So solve this question and let me know the answer. Everyone please solve it. Is there any doubt? Just stick with the definition of discrete metric spaces and find out what will this B of 0 comma 10 represents. So some of you are saying that it should be set of real numbers. Let's see what the answer will be. So yes, correct option is B, that is set of real numbers. So as going by the definition, B of 0 comma 10, it is centered at 0, that is open ball centered at 0 and radius 10. Fine. So this will represent a set where x, it contains all x belongs to R, such that D of 0 comma x is less than 10. Okay. So here that is the distance for all x such that from 0 such that its radius is less than 10. Okay. So you have to find that open ball that contains all, you have to find all the number of x such that it satisfies this. And again, you have to take care of that it is a discrete metric space over R. Okay. So as it is discrete metric space, so definitely all x will satisfy this criteria for real numbers. So b of 0 comma 10 will be equals to set of real numbers. Since discrete metric space is what? It contains also 0 and 1. So the correct option is B, that is R, set of real numbers. Okay, so do you have any doubts? Is it clear to everyone how it's a set of all real numbers? Okay, so it's clear to everyone. So let's move to the next question, shall we? Okay, so next question is, let X be a set that represents, that is consisting of two elements A and B. Okay, so then how many topologies on X having exactly three open sets? Okay, so basically you have given a set X consisting of two elements A and B, and you have to find the number of topologies on X such that it will have exactly three open sets. Okay, so you have to find whether it is 3, 0, 2, or 1. Fine. So just form topologies on this set X with taking in consideration the definition of topological spaces. So you will find how many such topologies exist. So everyone please try it. And let me know if you have any doubts and tell me the answer. If you have any doubts, you can just unmute yourself and ask, or you can write down in the chat box. So, is there any doubt? What okay, so you're asking about b of 0 comma 0. So what if in the previous question if it is b of 0 comma 0, right? 0. So okay. So you're asking Safu that is the elements of X are open. Yes, if as we have discussed about it, tau open sets. So the subsets, pardon. Okay, so the yeah the if it is if it is a subset that forms the topology, then it will be open set in that topology. So okay, so you have doubt that you are asking about b of 0 comma 0, right? So in the previous question, what will happen if we have been asked about b of 0 comma 0? So just guess, if you have a center of 0 and radius 0, then what will be the answer according to that? It should be centered at 0 and radius 0 and with respect to the discrete metric space. So just put in the definition and see what you will get. So b of 0 comma 0, right? So as it is discrete metric space, and b of 0 comma 0 will be defined as a set of all x belongs to R such that d of 0 comma x will be less than what? Here radius is 0, so less than 0. Fine. So which are these x that with respect to discrete metric space will satisfy this condition? How many x belongs to R will satisfy this condition with respect to discrete metric space? Is there any element which satisfies it? No, right? So since D is a discrete metric, so the answer will be V of 0 comma 0 will be what? It's empty set, right? Since no such element exists, I hope it's clear to you now. With respect to discrete metric, there does not exist any such element such that d of 0 comma x is less than 0. So b of 0 comma 0 will be empty. Fine. And okay, so it's clear to you now, I guess, right? So what about this question? The current question, what will be the answer? How many topologies you will get satisfying the given condition? Someone is saying two. What about others? Zero. Someone is saying zero. Some and two others. Okay, so you are also saying the answer will be two. Let us see what's the correct option. Okay, so the correct option is C, that is two. Okay, it will consist of these two topologies, tau 1 and tau 2, having three open sets. Okay, so how did we get this? So just recall the definition of topological spaces. Here we have a set X consisting of two elements A and B. So what are its subset? X, empty set, singleton A and singleton B. Fine. So just form the topologies, the possible topologies on these subsets of X. So if we consider tau 1, so what will it be? The basic one, empty, empty set and the whole set X, right? So tau 1, if we consider empty set and X, so does it satisfies all the condition? Yes. Next, see, it satisfies the first condition that it has empty set and X. Then second condition also that if you take the intersection of empty and X, it will again in this set only, and its union also will be in these set only. Okay, so it satisfies all the three axioms. So tau 1 will be a topological space with respect to X. Fine. So tau 1 forms topology on X. Now let's see another option. But we have to find topologies with exactly three open sets. Here we have only two open sets, right? So this is not correct. Now let us go to the next option, that is empty X and what it will be? Singleton set A. Fine. So just check whether it satisfies the all the axioms. So yes, it has empty and X set X. First property is satisfied. Then second one says what? That intersection of any of the these sets should again lie in this set only. So it is lying. Just check for all that singleton set A and X, the intersection of these two is again singleton set A. And if you take with empty set, then it will be empty. It is again there. Fine. So it satisfies intersection property, then union as well, right? So it is a topology on X. Okay. As it satisfies all the three properties, including intersection and union, all those three. Okay. Now let's move to the third topology. Similarly, we can define phi, comma x, comma singleton set B, right? So as we saw for tau 2, this will also satisfy all the three axioms. So tau 3 is also a topology on X. Fine. Now what is the last option? Anyone? It will again contain empty set, X, and what? What are the options now? Anyone? What will be tau 4? What are the subsets that you can take here? Singleton A and singleton B, right? So tau 4 will, this is also satisfying all the three axioms. You can check at the intersection that is empty also lies here, and its union that is X that also lies. Fine. So you can see that tau 4 is also a topology on X. But this cannot be taken as it has how many? Four open sets. But we require topologies with having exactly three open sets. But here we have four open sets. Okay. So we have got only two such open sets, tau open sets. Sorry, we have got only two topologies having exactly three open sets. Fine. I hope it is clear to everyone. So basically, you have to just take your set and form the topologies and check which of the condition is satisfied. Okay. Is there any doubt? Now let's move to the next question. So here, let Gi is equals to open interval I minus 1, comma I plus 1. So Gi is an open interval which is of this form. Okay. It is an open interval from I minus 1 to I plus 1, where I belongs to integers. Then union of, you have to find union of set Gi such that I is greater than equal to 10. So you have to find what will this set be equal to. Okay. So you have to just find GIs and take their union and find which of the options is correct. Is it option A, that is R minus open interval minus infinity to 9, or B, that is closed interval 9 to infinity, or C, that is empty set, or D, that is open interval 9 to infinity? Which of the following options is correct? Just check it. All of you try this question. You simply have to just construct GIs and take the union. Okay. And I is greater than equal to 10. So see what you are getting. So someone is saying option D, and everyone try it, construct GIs and take the union. So again, Safu is also saying option D. Any other guesses? So let's just see what's the answer is. So you have to construct GI, which is given as open interval I minus 1 to I plus 1, and then you have to take the union. Fine. So how it will look like? Just take I greater than equal to 10. So let's start for G10. What it will be? 10 minus 1, right? That is 9, and then 10 plus 1, that is 11, right? Similarly, you can move for G11. What it will be? 11 minus 1, that is 10, and then 13, 12, right? Then G12, that will be 12 minus 1, that is 11, and then 13. Similarly, you can go on, and then you have to take union of all these intervals, right? So what you will get, just take their union and see what you are getting. Just check, just take the union and check what you are getting. So the correct option will be D, right? That is open interval 9 to infinity. Fine. How did you get that? You have to find union of GI such that I is greater than equal to 10, right? So you have to take G10, that is 10, sorry, sorry, it will be 9, comma 11. Then G11, that is 10, comma 12. Similarly, G12, that is 11, comma 13, and so on. And take the union, what you'll get? You'll get 9, comma infinity. Okay, as it is open interval, so you will get, as it's going till infinity, so you will get open interval 9 comma infinity. Fine. So as it is open interval, so it will be open interval 9 comma infinity. So the correct option is D. Option C is not correct, and even B is not correct, since you have here open interval. So answer will be with open interval. So this here it is closed, so it is also not correct. And what about A? What is R minus minus infinity to 9? What does it represents? So option A, that is, if you take a real line, so you have to exclude from minus infinity to 9. Okay. So you have to exclude this part. So what will be the remaining part? As it you are excluding till open interval 9, so it will be close interval 9 to infinity. And again it is option B. So this is also incorrect. Okay. So option A is also incorrect. So correct option is D. Fine. I hope it's clear to everyone. Have we got this? Is there any doubt? Is there any doubt to you? Anyone? So I hope it is clear to everyone. Let's move to the next question. So here you have been given a set Dn, that is open interval 0 comma 1 by n. Okay, so here Dn represents an open interval 0 comma 1 by n, where n belongs to natural numbers. That is the set of positive integers. Then what will be D3 intersection D10? So you have to find what is D3 intersection with Dn. D10. Okay. So just construct DNs, that is set open interval 0 comma 1 by n, and simply you have to find the intersection between D3 and D10. Okay. So find it whether it is option A, that is D3, option B, that is D20, option C. Okay, so here actually it's mistake, I guess. Wait. Here it should be actually D20. Okay, not D10. So you have to find intersection between D3 and D20. Okay, it is D20. So now find out what the correct option will be. Whether it is D3, D20 or open interval 0, comma 1 by 20 or both B and C. Okay. D3, D20, open interval 0, comma 1 by 20 or both B and C. Just check it what you are getting and let me know the answers. So you're saying that answer will be both B and C. Find out what will be D3 intersection D20. Others, what are your answers? So you are also saying option D. Let's check what is the answer. So correct option is D, that is both B and C. So as we have seen that dn is defined as 0 comma 1 by n, right? So where d3 will be what? 0 comma 1 by 3, and similarly d20 will be 0 comma 1 by 20. Fine. So you can see that you have these two intervals and you have to take their intersection. Now 0 comma 1 by 20, this interval is subset of 0 comma 1 by 3. So its intersection will be d20, right? That is open interval 0 comma 1 by 20. So both d20 is equals to 0 comma 1 by 20. Both B and C are correct. Okay, so correct option is D, both B and C. Okay, I hope it's clear to everyone. If anyone has doubts, you can ask. Is it clear to everyone? So next, let's move to the next question. It is also similar to the previous one. Here again you have dn, that is an open interval 0 comma 1 by n, where n belongs to natural numbers set the the positive integers. Then what will be d3 union d7? Okay, so you have to find out what is d3 union d7. So is it option A, that is one open interval 1 comma 1 by 3 comma 1 by 7, or option B, that is open interval 0 comma 1 by 3, or open interval 0 comma 1 by 7? Everyone just solve it and let me know what's the answer. So you are saying that answer is B. Let's check. So you are saying that the correct option is B. You have to just take both that intervals and check. Just take D3 and D7 and take their union. So what you're getting? So let's check what the answer will be. So here you have Tn, that is 0 comma 1 by n. So according to that, D3 will be what? 0 comma 1 by 3. And similarly, D7 will be 0 comma 1 by 7. So you have to take its union. So you can see that 0 comma 1 by 3 union 0 comma 1 by 7 will be what? It is? What will the answer? So yes, the correct answer will be B. That is 0 open interval 0 comma 1 by 3. Fine. Since you can see that open interval 0 comma 1 by 7 is subset of 0 comma 1 by 3, therefore you are getting the correct option as B. So yes, correct option is B. If you have any doubt, you may ask. Is it clear to everyone? Shall we move to the next question? Okay. So the next question is here that let the functions, you have given two functions f from R to R and g from R to R, that is set of real numbers. It be defined by f of x is equals to 2x plus 1 and g of x is equals to x square minus 2. Okay. So then which of the following product function will define g of f? So basically you have been given two functions f of x and g of x, that is 2x plus 1 and x square minus 2. You have to find the product function defining g of f. So what it will be, is it option A, that is 4x minus 1, or option B, that is 4x square plus 4x minus 1, or option C, that is 2x square minus 3, or option D, that is none of the above? Okay. So basically, you have been given these two functions, and that is defined as below, f of x and g of x. And you have to find what is g of f. Okay. So just put in the definition of these functions and check which of the following options is correct. Let me know your answers. So if you have any doubt, you can ask. Just unmute yourself or let me know in the chat box. So what are your answers? Is it 4x minus 1 or 4x square plus 4x minus 1? So you have to just substitute the values in f of x and g of x. So you have here f of x is equals to 2x plus 1. You have to find g of f, right? So what is g of f? How it is defined? So g of f is defined as g of f of x, right? So you have to just put here what is function f of x given to you. So it will become g of f of x, that is 2x plus 1, right? So it will become g of 2x plus 1, correct? G of 2x plus 1. Now we have to consider this 2x plus 1 as your variable, right? So what it will be, as here you can see, yeah, g of x is defined as x square minus 2. So just in the place of x, you have to substitute 2x plus 1 and see what you are getting. So how it will be? So g of x, if it is defined as x square minus 2, then what will be g of 2x plus 1? So just at place of x, put 2x plus 1 and see what you are getting. So what will be g of 2x plus 1? Anyone? So this will be equal to what? Anyone? Have you solved it? Just try. So what is the answer you're getting? So what is the answer you're getting? Shall we move to the answer? Okay. So accordingly, just substitute f of x at the place of x here. So you will get what? So g of f will be g of f of x, that is g of 2x plus 1, and that will be equal to, so as x is mapped to x square minus 2, so 2x plus 1 will be mapped as what? So here g of 2x plus 1 will be what? 2x plus 1 whole square, as it was x square minus 2. So here you will get 2x plus 1. Okay, so g of x is equals to x square minus 2. So g of 2x plus 1 will be what? Just at the place of x, put 2x plus 1. So you will get 2x plus 1 whole square minus 2. Okay, so expand it, what you'll get? 4x square, 4x square plus 4x plus 1 minus 2, right? So this is equals to 4x square plus 4x minus 1. Okay, I hope it is clear to everyone. So g of f of x will be equal to 4x square plus 4x minus 1. So the correct option is B. I hope it is clear to everyone. If you have any doubt, you may ask. So if it is clear to everyone, let's move to the next question. It is let A is equals to set of 1, 2, 3, 4, 5, and let F from A to A be defined by the diagram. So here we have set A and function F defined from A to A. It is defined by this diagram. So here we have taken set A as a Venn diagram from A to again A. Okay. So here these elements are mapped to the codomain in this manner. You can see. So if here we have function F from A to A and mapping is given as in the diagram. So here 1 is mapped to 4, 2 is mapped to 1, 3 is mapped to 4, 5 is mapped to 4. Okay. And you have to find what is F inverse of set consisting of 3 elements 2, 3 and 4. Fine. So what it will be? You have to simply find the elements 2, 3, 4 in codomain, and you have to find that which elements in the domain are mapped to these elements 2, 3, 4. So whether it is option A, that is singleton set 1 comma 4, or option B, that is sorry, set 1 comma 4 and then set 1 2 3 4, or option C, that is set of 1 4 3 5, or option D, that is set A. So just check what you are getting as F inverse. So are you getting it as option C? So correct option is 1 4 3 and 5. That is option C. Okay. So here you can see that the function F is mapped from A to A, right? So you have to find F inverse of elements 2, 3 and 4. So what will be its inverse? So basically you have to see in the codomain the elements 2, 3 and 2, 3 and 4, and Just check which elements in A are mapped to this elements 2, 3, and 4 from domain. So for 2, which element is mapped to 2? So it is 4, right? So you got 4. Then which element is mapped to 3? None. Okay. Now which element is mapped to 4? So there are 3 elements that are mapped to 4. That is 1, 4, 1, 3, and 5. Okay. So basically you got F inverse of 2, 3, 4 as set of 4, 1, 3, and 5. Okay. So option C will be the correct option. Fine. I hope it is clear to everyone. Is there any doubt? Okay, so it's clear to everyone, right? So shall we move to the next question? So the next question is, if let x is equals to, let x is equals to set of A, B, C, D, and E. Okay. Uh, so determine which of the following classes of subsets of X is a topology on X. Okay. So first of all, tell me what is classes? What do you understand by the term class? Anyone? Okay. So you're saying that it's a collection of subset. Okay. Fine. Class is what? It's a collection of subsets. So you have been given the set X and you have to determine which of the following classes of subsets of X is a topology on X. Okay. So check which of this following is defines topology on X. So is it option A, B, C, or D? So for checking it, just check all the three axioms for satisfying being topology on the given X and see which of the following satisfies it or none of these satisfy being topology on X. Just check all the three axioms for each of the sets. If you have any doubts, ask. So you are saying that option D and someone is saying option C. So some are saying option C and some are saying option D. Just check wisely all the axioms and let me know which one is correct. So you're saying option D, none of the above. So I'll again say that just check all the three properties nicely and see if any of this satisfies being topology on X. So let's check one by one. So first of all, that it should contain X comma X and F empty set. So all of these three contains X and empty set. So it is satisfied. Now for tau 1, let's check the second property, that is union of any two subsets should be again in tau 1. Okay. So taking the union of singleton set A and set A comma B. So what you'll get? It is again in this set. Then third, so if you'll take union of these two, then it satisfies, right? Then if you take union of these two, then again what it will be? This will be okay. Now taking intersection of A comma B and A comma C, that is singleton A, that is there in this set. Now taking union of these two sets, what you will get? Union of A comma B and A comma C, you will get what? Set of A comma B comma C, right? So is it there in this set tau 1? Does this set exist in tau 1? It is not there, right? So as union of two sets, subsets of X does not belongs to tau 1. So this is not a topology on X. Fine. So it fails that property that any two subsets in tau 1, its union should also be in tau 1. Now let's check for tau 2. Again here X and empty are there in this set. Okay. So first is satisfied. Then now next moving to the second property. So what is that? Now taking union of these two sets. So it's what? A, B, C, D, right? So its union will be set A, B, C, and D. That is again there in the set, right? Now taking union of these two sets. So as it is subset of this, so it is again in this set, right? Similarly, ABC is also subset of this, so its union is also there in this set. Okay. Now taking intersection. Now let's check for intersection. Now intersection of ABC and ABD will be what? Set. Which set it will be? Intersection of ABC and ABD will be what? A and B, right? Is it there in the set? Is it there in tau 2? No, right? So here it fails as intersection of two subsets in tau 2 is not there in tau 2, right? Now let's check for tau 3. So again here X and empty set are there. Now check for these two sets, their union. Take any two sets and take their union. See, it's again in this set. And take any two sets and take their intersection and check that its intersection is again in this set, right? So check one by one for each of these sets, and you'll find that its union and intersection is again in this set, right? So it satisfies all the properties of being topology on X, right? Is there any doubt? Is everyone able to satisfy all the properties for tau 3? Is there any doubt? Okay. So tau 3 satisfies all the properties of being topology on X. So we got our answer. So as we got tau 3, so D option is not applicable. Okay. So correct option is C, that is tau 3. Okay. You can see here that if we take set A comma B and A comma C, that belongs to tau 1, but its union, that is ABC, does not belong to tau 1. So tau 1 is not a topology on X. Similarly, for option B, if we take ABC and ABD, so its intersection, that is AB, does not belongs to tau 2. Okay, so tau 2 is also not a topology on X. And tau 3 satisfies all the necessary axioms. So the required topology is tau 3. Okay, I hope it is clear to everyone. If you have any doubt, you may unmute yourself and ask or write down in chat box. Okay, so it's clear. So Samuel, do you have any doubt? So you're saying about which? So in tau 3 you are asking about. ACD and ABCD. Okay, so you're saying that its intersection does not lies in this set. Okay, let's check it. So if you have this If you take these two sets and take its intersection, what you will get? What will be the intersection of these two sets? A, C, D, and so if you have these two sets, A, C, D and A, B, C, D, so its intersection will be what? What will be its intersection? What will be its intersection? A, C, and D, right? These three elements will be there. And ACD is there in the set, right? So intersection also belongs to the set, right? So I hope it is clear to you now. So I hope it's clear to everyone how tau 3 is topology on X. If anyone still has doubt, you can ask. And if it is clear to everyone, then we will move to the next question. So I hope it is clear to you now. Okay, fine. So let's move to the next question now. So next question is, let D1 be defined as from R2 cross R2 to R, and it is defined as d of x comma y is equals to modulus of x1 minus y1 plus modulus of x2 minus y2. Okay. So here you have a function d1 from R2 cross R2 to R, and it is defined in this manner since it is from R2 cross R2 to R. So elements in the domain will look like x will be x1 comma x2, it will be two tuple. Then similarly y will be y1 comma y2 and z will be z1 comma z2. Fine. So now state which of the following properties is not satisfied by D1. So you have to find which of the given following properties is not satisfied by the defined D1. Okay. So you have to check all these three properties, or if it is none of the above. So first, that is d1 of x comma y is greater than equal to 0, that is non-negativity. Then B, that is if d1 of x comma y is equal to 0, then x is equals to y. Okay. Similarly, you have to check for C, that is d1 of x comma y is equals to d1 of y comma x. So or it is none of these above. That means all the properties will be satisfied. Okay, so be careful with the options and check all these three properties and let me know which of this is not satisfied by D1. Here, actually, it will be D1 of x comma y. It is D1 of x comma y. So now we have your function and just check all these three properties. If you have any doubt, you may ask. Just unmute yourself and ask your doubts, or you may write down in the chat box. Everyone try it. So you are saying option B. So just check. Everyone try it. If you have any doubt, if you are facing any problems, you can ask. So you are saying option D. That is none of the above. I'll say again that please check all the options wisely and see which of this following is not satisfied by D1. Check one by one. So you're saying some are saying option B and some are saying option D. So what is the correct option you are all getting? B or D? So shall we move to the answer? So let's proceed. If you are trying, so we will wait. So shall we move to the answer part? So here, as you have been given d1 of x comma y, as it is mapped from R2 cross R2 to R, and it is defined as this. So let's check all the properties one by one. So first you have to check non-negativity. So let's check it. So here you have to check for d1 of x comma y is greater than equal to 0 or not. So basically the correct option is D, that is none of the above, since d1 is the metric space and satisfies all these properties A, B and C. So let's see first how it is satisfying these properties. So first let's come to A. So you have to check whether it is non-negative or not. That is, you have to check for d1, that is R2 cross R2 to R, and defined as d1 of x comma y as modulus of x1 minus y1 plus modulus of x2 minus y2. Okay, so write down d1 of x comma y is equal to modulus of x1 minus y1 plus x2 minus y2. So what is this? This is always greater than equal to 0 and this is also always positive, right? Greater than equal to 0. So its sum will be always greater than equal to 0. Okay, so option A is correct, right? That is, it satisfies. Now let's check for B, that is, if d1 of x comma y is equal to 0, then x is equals to y. Okay, so let's check it. So consider d1 of x comma y is equal to 0. Now when it will be 0, just write down its definition, that is if and only if modulus of, how it is defined, modulus of x1 minus y1 plus modulus of x2 minus y2 equals to 0. Now the sum of two positive um, terms will be 0 when it will be 0, when this terms will be individually equal to 0, right? So if and only if modulus of x1 minus y1 equal to 0, right, and modulus of x2 minus y2 equal to 0, fine. So we'll get modulus of x1 minus y1 equal to 0 and modulus of x2 minus y2 is equals to 0, fine. Now let's, now when it will be 0, when modulus term of any term will be 0, when that term will be 0, right? So x1 minus y1 is equal to 0. And similarly here you will get x2 minus y2 equal to 0. So this will be equal to, this will imply x1 is equal to 0 and x2 is equal to 0. So finally the tuple x1 minus y1, x1 minus x1 comma x2 will be equals to y1 comma y2. This will give you x is equals to y. Okay. So the second property is, that is d of x comma y is equal to 0 if and only if x is equals to y is satisfied, right, by d1. So this option is also not correct, right? Now let's move on to the third option, that is symmetricity. You have to check. So let us write down d1 of x comma y. It is defined as modulus of x1 minus y1 plus modulus of x2 minus y2. Now, since this term is in modulus, so you can take out minus common. So you'll get modulus of minus of y1 minus x1, right? Plus modulus of minus of y2 minus x2, right? Now, as it is a modulus, so this minus term will become positive. So you will get modulus of y1 minus x1 plus modulus of y2 minus x2. Correct? So this will give you. Now this is similar to our definition of d1 of x comma y. Just at the place of x1 you have got y1 and at the place of y1 you have got x1. So this will become d1 of y comma x. So this property is also satisfied, right, by d1. That is, you got d1 of x comma y is equals to d1 of y comma x. So symmetricity property is also satisfied. So this option is also not correct because we have to find which is not satisfied by d1. So A is also satisfied, B is also satisfied, and C is also satisfied. So the correct option will be that which is not says that which is the property not satisfied. That is none of the above. That means all these above three properties are satisfied. Okay. So the correct option is D. Fine. So all these three are incorrect. The correct option is option D. That is none of the above. Be careful with the options also. Okay. So the correct answer is none of the above. Okay. I hope it is clear to everyone. Have you got this answer? If you have any doubt, you may ask. Okay. So you can see that all these three properties are satisfied. Even the fourth property of being metric space, that is triangular inequality, it is also satisfied by D1. So that's why D1 will become a metric space. Okay. You can check it. That is d1 of x comma z is less than equal to d1 of x comma y plus d1 of y comma z. That is a triangular inequality property. You can check and verify that this property is also satisfied by d1. Okay. So d1 forms a metric space. Okay. I hope it is clear to everyone now how d1 is the metric space. And it is a standard one. Okay. So in the following manner, we have got the answer as D. If you have any doubt, you can ask. So similar type of questions you may get, like checking which of the properties are satisfied, or topologies, how many topologies you can form with a given number of open tau opens sets. Okay. And similar kind of questions you can expect. So any doubts if you have regarding the questions we have discussed, you may ask. Thank you for joining, everyone. So if it is clear to everyone, then thank you for joining to this session. And If you still have any doubt, you may ask. Similar type of questions you can expect. If you have any doubts, you may write in the comment section. Thank you, everyone. Thank you for joining in this doubt session. So, I will. Okay, so you're asking about when I will upload this session. So maybe by tomorrow I will upload it. By today or tomorrow, I'll try to upload.